Starting with question number 1. This is for Group 1 Alkali Metals. This is the first worksheet.
Lithium, sodium,
Let's
cesium.
zoom out a little bit.
Lithium, potassium, cesium, and 3 alkaline. A small piece of each metal is filled in water and the super complete table of China explodes in contact with water. Cesium.
The first one is cesium, right?
Lithium.
Lithium.
Potassium.
Good. Potassium, finally. B1.
Give the name and the formula of the gas formed when potassium reacts with water. Hydrogen. Sir, with
Right,
all the metals, hydrogen is formed, right?
right. Whenever a metal reacts with an acid, hydrogen gas is formed. Apart from that, since this chapter is not about acid, sorry, my bad. Whenever very reactive metals from group 1 reacts with water, they form hydrogen gas along with that salt.
All right.
Not a salt, wait. A hydroxide, not a salt, hydroxide.
Yeah.
मैं मुसलसल एसिड वाले चैप्टर के आंसर बता रहा हूँ सॉरी this is alkali metals, right? Okay, moving on, part 2.
Give the name of formula of the compound formed when lithium reacts with water. Lithium hydroxide. Formula will be wait, oh yeah, LiOH.
LiOH, right? And which letter would be small in all of these 4 letters?
I.
Okay, perfect. Moving on. Next one.
Describe how you could show that an alkali solution is formed when cesium reacts with water.
And really doesn't belong to the same chapter, but yeah, you can go ahead.
Uh,
Since the teacher might put it as a part of your test, let's go ahead with this. Although this does not belong to the same chapter, this belongs to acid bases and titrations chapter. How do you show that a solution is alkaline? Think about the chapter we are recently done with acid, alkalis, and titration.
sir, like measure the pH so that we can know if it's alkaline or acid or base, right?
That's somewhat a longer method, but yeah, that's correct. So how would you know that this is alkaline? So the answer you've just given can get you 1 mark. How would you know, or what the pH would be in order to know that it's alkaline and not acidic?
For alkaline, it was um, 7.
7 is neutral. 7 is neither acidic nor alkaline. How would you prove it is alkaline?
Um, I don't remember the number.
Yes.
Right.
If you don't remember the number, remember 7 is neutral, greater than 7 alkaline, smaller than 7 acidic. Okay. Your answer was still incomplete. I'd like to ask you, what are you going to use to measure the pH?
Um,
Because you missed out on this small piece of detail.
sir, isn't that what's that called? Universal indicator?
It won't give you the pH in numbers.
Uh, or there is like one type of like like paper. Um, that one.
No. pH meter is the one that gives you pHs in numbers. A universal indicator paper actually changes its color or even the solution. So it's better to go with indicator solutions or paper. And yeah, that is litmus paper. The easiest way to go for it is using a litmus paper. The red litmus paper will turn to blue in an alkaline solution. Okay? If you're
Yeah.
using universal indicator paper, it would show you any colors from blue, violet, or indigo to show you it's alkaline. If you're using a pH meter, it would show you a pH greater than 7. It can be anything. It can be 10, it can be 11, it can be 12, 13, 14. So you can't quote a single number, and that single number can be right or wrong. Don't know how much of water reacted with cesium. So a very precise answer would be greater than 7. अब ये जहन में रखना है, जब आपने pH numbers कोट करने हैं तो आपने pH मीटर यूज किया होगा। जब आपने pH की रेंज फाइंड आउट करनी है तो आप यूनिवर्सल इंडिकेटर पेपर या सोल्यूशन यूज कर सकते हैं, लेकिन उसके डिफरेंट कलर्स आते हैं। ठीक है। और फाइनली जब आपने सिर्फ ये बताना है कि वो एसिडिक है या अल्कलाइन है, आपको pH नंबर से कोई फर्क नहीं पड़ता, तो आप ब्लू या रेड लिटमस पेपर इस्तेमाल करेंगे। रेड वाला ब्लू में कन्वर्ट हो जाए तो अल्कलाइन है, और ब्लू वाला रेड में कन्वर्ट हो जाए तो एसिडिक है। दैट्स हाउ इट वर्क्स।
Alright.
All right.
Sir,
So red to blue, alkaline, blue to red, acidic.
yeah.
I
So, sir,
totally
how would
forgot the fact that I tend to record most of my videos in English. I kept on going in Urdu. I hope you don't have a problem with it.
yeah, I don't have problem.
Okay,
Sir,
okay.
so how would I exactly write the answer over here? Like by explaining as well.
Yes, the most the easiest one that you can choose to write over here would be using in the litmus paper. The blue litmus paper would turn to red in alkaline solution. Okay, so
Okay.
that is going to be a perfect answer. Let me also show you that on the marking scheme. Okay, so you can use even the solution. So you add red litmus, it turns to blue, or you use a pH meter, it shows you a pH greater than 7. All right.
Yeah.
Okay, good. And by the way, for acceptance, you can use any named indicator and you can use the correct color. Okay.
Yeah.
Good. So remember, you can't use a blue litmus paper because there will be no difference in that paper. Okay, this is a different question, really does not belong to alkali metal chapter. Let's skip this one. This one is about ionic bonding. Yeah, this part B belongs to alkali metals.
The chemical equation with okay, lithium, okay, lithium and nitrogen.
There was a small equation in there, very small part in there, where we did this equation.
Okay. It'll be lithium plus nitrogen like N2, then arrow, then LIN. Now if we balance it,
No, it's not LIN.
no, it's not.
No, it's not. It's not the correct formula. So you just told me, and I'm going to write it over there so it's easier for us to understand what we're doing imaginary. So you told me that you're going to take lithium. You told me that you're going to react it with nitrogen gas, which is N2. And then you gave me this formula LIN. I'm telling you this formula LIN is not correct.
No, sir. I still not add the numbers. I will do that.
Okay, go ahead. Fine. Add the numbers.
Oh, okay.
I'm not talking about balancing the equation. You're supposed to balance the equation once you're done writing the correct one.
Oh, okay. So, sir, what's wrong over here?
Nitrogen does not have a charge of +1. It does not belong to group 7 or -1. It does not belong to group 7. So it can't be Li3N. Oh, it can't be LIN. It is supposed to be Li3N. Okay, so मैंने आंसर बता दिया. So let's correct it up. So it's Li3N. Why? Because nitrogen belongs to group 5. It would take 3 electrons, which means lithium would form a positive ion and nitrogen would form a nitride ion, which is -3. When we cross multiply these as subscripts, this would become Li3N. Make sense? Why? Because
Mm-hmm.
nitrogen is in group 5. Gaining 3 electrons would stabilize the outermost shell with 8 electrons, an electronic configuration similar to neon.
And now, sir, over here, like nitrogen has two and will add two, like in front of lithium, right?
Yes,
And then it'll be 2 into 3, 6. So in front of that fresh lithium, which is 0 right now, it'll be 6.
right. Is the equation completely balanced?
Uh-huh. Yeah.
Good, perfect, it is. Okay, let's clear all of this up. Moving on. Hmm, since we
Lithium.
need to talk about part C2, so let's talk about part C1 as well. Though
Alright.
C1 not exactly a part of the alkali metals, but in order to do C2, it acts as a prerequisite.
Uh-huh. All right. Sir, I have to do part 2 or 3?
Let's go with part 1 first, then we'll do the part 2.
All right. Lithium nitrate.
These are just
Yeah.
state symbols, so it should be easy.
Um, so, sir, the last one is obviously gas, right? Because it's
Perfect.
nitrogen. Uh-huh. And then lithium. Right. Okay. Here also we have gas, hydrogen and oxygen. So, mm, sir, the first one is liquid because it's water, right?
Stay with me. I have a little bit of an emergency. Please stay on the
Yeah,
call. Thank you.
yeah, yeah.
So, what would be the states for H2O and LiOH?
Sir, for the first one, it's liquid because it's water,
Right.
and after that, I think it's aqueous.
Aqueous, because the first group 1, their compounds, most of them are soluble. Okay. So, part 2.
Sir, from 7 to 14.
And the reason?
Um, is it that because lithium hydroxide is an alkali?
Right. Lithium hydroxide is an alkali. Good. Moving on. Let's clear this one up. Okay.
This
A good question.
which of the following is correct about conductor? Okay. Let's see.
Good. Basic oxide means an oxide which, when dissolved in water, forms an alkali or a base. Okay, moving on, part P1.
Okay. Um, so sodium is added in the large. Okay, sodium. Sir, it will melt into the water and it will form like a ball because of like low melting point.
Right.
And the other point would be that it disappears like in the water.
Good. That ball actually reacts, produces effervescence, disappears in the water. There can be many things that we can write over here. Good. But try preferring effervescence or production of a gas or bubbling with it.
Mhm.
Okay.
All right.
Moving on.
Com
Part two.
complete the equation. Okay, state symbols. Uh, Last one is obviously liquid.
No.
No, gas. Sorry, yeah, gas.
Right.
Second is I mean, the first one is liquid,
Right.
and this one.
Again, it's an hydroxide,
Oh, aqueous.
aqueous. All right. So moving on.
Okay, potassium. Okay, skeleton. That would be made of potassium. Iron. So why do they always ask about water? Like if they are like dropped in the water, what would happen? Because I've seen many questions. That's why.
There are basically two to three main reactions that we have studied for alkali metals. The first one is tarnishing, which means reaction air or reaction oxygen, what we call it, and it changes its appearance. So usual questions are either about that one, or the second main reaction is reaction with water. They may ask that question too. Apart from that, there are two more reactions: reacting with halogens and forming salts, or reacting with uh, no, that's about it. Reacting with halogens forming salt. So since these are the three main reactions we go with, they tend to ask questions about these three main reactions. Now, among these three main reactions, the one that can be considered most because of the ways the question can be changed is the reaction with water. Since there are more than one observation, since there are more than one result, equations that we can write, so they tend to go with the most obvious one.
Mm-hmm. Okay,
They
for
give
potassium,
Yeah, go ahead.
yeah.
Go ahead. Go ahead.
Uh, Sorry, gas is hydrogen gas is produced.
Right.
Yeah, that's it because it's for one bar.
But the gas is also produced with sodium.
State. Oh, okay. But it would not be okay. Okay, all right. Would not be absorbed with sodium. Mm, forms lactic flame.
Lilac flame, right. Actually, to begin with, you need to write that it catches fire. That
Uh-huh.
piece of potassium catches fire, and that fire is actually the lilac flame. Try to make more sense out of it. वो कहेगा कि फ्लेम कहाँ से आया? लाइलैक आप बता रहे हैं तो पहले उसे बताएं कि उसे आग लग जाएगी. It would turn to flames first, and then you'll be able to see the lilac color in those flames. Right?
Yeah.
So always try to make it easier to understand for the reader. Though the reader is the examiner and probably knows stuff first, but the more sense you're going to make out of it for him, the better your answer is going to be rated at.
Mhm. All
Okay,
right.
moving on. D,
Explain why the elements in group one because they have a similar valence electron in the outer shell.
similar valence electron configuration or electron arrangement. And yes, that is correct. Good. Okay, moving on.
There are three.
No, 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 almost no. Yes, this one. Let's start with this one. The previous
This.
ones didn't belong to the chapter alkali metals. That's why I skipped those. So 7A.
Right. Is correct about lithium. Lithium is a non-metal. Lithium forms. Okay. Lithium. C.
Good. B.
Lithium and potassium have similar chemical properties because their atoms have okay. Sorry, A.
Good. Let's move on to part C.
More pieces of lithium, potassium are added to separate large okay water. They two numbers that would be similar for each, and one would be different for them. Okay. Lithium and potassium. But potassium melts in water, right?
Yes, it does.
So lithium doesn't melt in water.
Somewhat true, yes.
So it would be like okay for the different part, like one of the melts and the other one doesn't.
Yes, you can, but it's better if you write potassium quickly melts or violently melts. So the adjective clarifies your statement further.
All right. Okay. Similar. Um, mm, there's similar that it would be like both of them like float in water
Right. Both of them float
or
in water.
like
Apart from that, both of them will show bubbling or produce a gas in terms of effervescence, bubbling, fizzing. It's just
Mhm,
that one of them will uh, show slow fizz and one of them will do it in a very violent manner, lithium and potassium, respectively. So
mhm.
fizzing or bubbling, producing a gas is similar them for both of them. Producing an alkaline solution is similar for both of them, which can then be tested with litmus paper. Okay, moving on. D.
Suggest the formula of the compound formed when potassium reacts with oxygen and potassium reacts with chlorine. Potassium, potassium hydroxide, right?
No,
No.
it's not reaction with water beta, it's reaction with oxygen,
So potassium oxide.
right? But since we're talking about the formula, so you need to tell me the formula and not the name.
Okay. Um, so let me
Though the
just
name is correct, but that's not how it works.
yeah. One second. Let me just see the periodic table. Um, okay. Potassium. Okay. So it would be K2O.
K2O, good. And
Chlorine. What's chlorine? Chlorine. Okay. It would be KCl.
KCl. Perfect. Okay, moving on. The equation, part E,
Um. All right. The last one is hydrogen, so gas. Uh.
right?
Then. Oh yeah, the second last it's aqueous,
Right,
then it's liquid, second,
right,
and solid.
right. Good. The next one doesn't belong to the chapter exactly, so let's skip that. Moving on. Question number 8.
The table gives information about the first three elements in group one in the periodic table. Okay. Which of these shows the chemical properties? Similar chemical. Chemical, not physical. Chemical, let it be electronic configuration.
Right.
Reason because um, all of the elements in group one have the same number of electrons in the outer shell.
This time you have the configuration right in front of you. So be very exact. How many electrons are present in the valence shell of each element?
Okay, each element in the group one will have one valence electrons in the outer shell.
One valence electron and one valence electron. That's about it. Because since you're calling it valence, you don't need to say the word outermost shell again. So one valence electron, hinting to just one at the end of it. Okay, B. And let's stay over here so that you can see the table.
Sir, melting point?
And what is that? What about the trend, I mean?
Identify a
Although they
physical.
haven't asked the trend, but I want you to go ahead and discuss it. So what's happening to melting point? What
It's
kind of trend do you
decreasing.
see?
It is decreasing as we go like down, I guess. Yeah.
As we go down the group, the melting point is decreasing. Very good. Okay, moving on. Part C.
The elements also show some clear chemical
You can't
properties.
really do that. You can't do C1 because that's chapter 18. You haven't done that yet. Part C2 is something that we have practiced way too many times, and let's not do that. Part C3.
Okay, this time it is lithium and potassium with water. So we have to give two each, right?
Sorry?
We have to give two each, right?
To each what? I don't get the point.
Like similarities two and difference also two.
Part 3. That's part
Oh, okay.
D that you're doing. Let's do three
Okay.
first, and then we'll get to D.
Oh yeah, I did not see the
And yes,
third.
you were right with two similarities and two differences. 4 points in total. But let's
State.
do three first.
Okay. State the effect of um, this one? I don't think so. I know this one. Uh,
We've just talked about that they form alkaline solutions. So the red litmus paper will turn to what?
blue?
Blue. That's it. It forms an alkaline solution because of which the red litmus paper turns to blue. 2 points, 2 marks. Okay, moving on to D.
Okay, similarities between lithium and potassium. Sir, in difference, we can write that lithium fizzes like gently, whereas potassium is like violently, I guess. Yeah,
Right.
right. Violently,
That
yeah.
is good.
And also, what else? Lithium doesn't melt, but potassium melts violently. No?
Okay.
Okay, similarities. They both like move around the water and then they float.
Right. The second similarity, last point.
Uh, Bubbles are formed.
Right. Okay, part E, part 1.
And lithium brines, okay. Write the chemical equation of lithium and reaction of lithium plus oxygen, then
Right. Li plus O2.
plus
What else?
O2, lithium 2O,
Li2O, as mentioned over here. Good enough.
Li2O. Now we have to balance it. So we have lithium 2. Okay. We need two oxygen, so we'll add it at the front. So it will be 2 into 2, it will be 4. So then lithium, which is 0, it would be 4. And
It isn't 0, it's 1, by the way, but yeah, keep going.
so it's not 0?
It's 1. When there's nothing, it means it's 1. 0 means it's not there, it's absent. Come on.
No, sir, it's 0.
No, it's 1, beta. When you write x in algebra, it means 1x, not 0x. 0 means x does not exist. The same happens to elements. When you write an element, that means there is only one mole or one molecule or one atom there. Singular identity.
Alright. So oxygen, we have 2 over here, but here we have 1. So we'll add, in front of lithium, we'll add 2.
Good. That's balanced. What about the balancing in second part?
Okay, so here we have 2 sodium. So we need, so we'll add 2 into 2, 4. I'm not sure. Sir, at the first one, we'll add sodium as 2 because over there it's 2.
Good.
And then oxygen. We'll not add anything because it's
No,
already
you
done.
can't leave a blank empty. Need to
So
write
1,
something. 1. Very good.
here also 1.
1. That's good. Thankfully, he didn't call it 0. So yeah, that's 1. And now you understand the point as well. Okay, so this completes this one. Let's clear it up. Let's close this one. Okay, let's close this one too. Let's talk about this one. I'm gonna zoom out a little bit so it's easier. Okay. Question 1, part A does not belong to this chapter. Let's skip it. Neither part A1, neither part A2. So let's move on to part B. You've already told me about part B, so no. No. Okay, let's solve part B. I have already filled in the missing portion, so I hope that works for you.
the electronic configuration of lithium and potassium are why potassium is more reactive. Sir, is it reactivity series?
No, it's totally electronic configuration. Remember, there was some extended portion at the end of the chapter where we discussed why, if lithium is less reactive than potassium, or sodium is less reactive than potassium, there were structures drawn, electronic configuration, nucleus, outer shell electrons.
Oh yeah, because I think potassium will be like, I don't know how to say it in the nice words, but like it is more near to the nucleus.
In
Potassium.
case of potassium or in case of lithium?
Um, Lithium.
It's closer to the nucleus in case of lithium because it has a smaller structure. Good.
What else?
So how does that affect it?
Because it's far from the nucleus, so the attraction is like less.
Right. So the attraction is less and it's far from the nucleus in potassium. So the electron is lost easily, and that's why potassium is more reactive.
What will be the second point? Oh, sir, I don't know the second point though.
You've already told me the second point. The first point was in case of lithium, it's closer to the nucleus and it's farther from the nucleus in case of potassium, which means lithium has a smaller structure and potassium has a bigger one. That was the first point. The second point is since potassium has a bigger structure, electron is lost easily and it's more reactive. So that's the
Alright.
second point. And the same thing is mentioned if I move on over here. And if I go all the way, so potassium loses its outer electron more easily or readily. That's because it's farther from the nucleus and there is less attraction. So good, 2 points. You can either talk about potassium or you can go for the reverse argument and you can talk about lithium. Since you talked about both, your answer was bigger, but that's fine. If you can manage writing it in the set time, that's completely all right. Right? We're done with the
Yeah.
first question. We can start on with question number 2 later. Or